Everybody, in this video, we're going to talk about what a function is, as well as how you can help your students start to develop functional thinking, even if they don't necessarily know the functional notation yet. So, the basic idea of a function is that you're comparing two variables that are changing in relationship to each other. So, for example, one thing you could use a function to represent would be the terms of a sequence, because you could have one variable represent the term number, like whether it's the first term or the second term or the third term. And then the second variable could represent the value of the term. So you guys have done a lot of work with various sequences and various patterns in your conjectures, and all of the equations that you found as part of those conjectures are functions because they're relating two different variables to each other. So the notation for a function in high school at least, is represented like this. So you have f for function, and then the x is the input of the function. And the way that you read this is the function output when you input an x into the function f. Now, usually we don't ever read it that way, but that's technically what it means. Usually it's read as f of x, but what it means is the output when you input an x into the function f. And then we write the function rule. So a simple function rule might be x plus 2. And what that means is whatever x is, whatever your input is, you just take that number and add 2. So if I input a 5, my output would be a 7. If I input a 7, my output would be a 9. If I input 100, my output would be 102. So that's how functions are typically written in high school, but you can still help your students start to develop functional thinking before they learn this notation. And if you want to, you can tell them that you're going to tell them something super advanced and you can introduce this notation. Um, but the way that you can introduce it without the notation is with a game that's called Guess the Rule, or you can call it the function game if you want to. But the basic idea is that you tell the students that you're going to input a number into this machine, and the machine is going to apply some rule to the number and give an output. And you're going to tell them what the inputs are and what outputs you get when you input that number. So, for example, you might say, I'm going to input a 2, and the machine gives me a 10 as my output. Then I'm going to input a 7, and the machine gives me a 35 as my output. And you can also have the students get engaged with this as well, and you can say, what number should we input next? And the students might say, oh, let's input a 3. And you can say, okay, well, the output is a 15 when you input a 3. And by this point, they might have a prediction that the function rule is that you multiply by 3. And if you want to teach them the functional notation, you can say that that means that f of x equals x times 3. And actually, maybe you might not want to use x because it looks kind of like the times symbol. You might want to say like f of the input equals the input times 3, because changing that variable might make more sense to the students. Um, so that's one way you can start to introduce functional thinking, even if you don't introduce the functional notation. And another way that you can introduce functional thinking to your students is to give them patterns or word problems that involve patterns and ask them to come up with number sentences that allow them to calculate the extension of those patterns. So, a common story problem that shows up in some of your case studies is the idea of a penny jar. So, if a penny jar starts with 5 pennies and each day you add 3, you could ask your students, how could you figure out how many pennies are in the jar on day 10? And so, different students will come up with different strategies and they'll come up with different number sentences for calculating them as well. Because one student might say, oh, well, I start off with 5 pennies and then I add 3 pennies on day 1, then another 3 pennies on day 2, day 3, day 4, day 5, day 6, day 7, day 8, day 9, and then day 10. And they would add up all of those numbers and they would find that there are 35 pennies in the jar on day 10. Other students might have other strategies and they might say, well, I know if I'm adding 3 and then adding 3, adding 3, adding 3 for 10 days, that's the same as 3 times 10. And so I can do 3 times 10, but then I also had 5 pennies to start with, and that gives me 35 as well. Because if I do 3 times 10, that's 30 pennies that I added, plus the 5 pennies that I started with, and that gives me 35. And this type of thinking is actually very, very helpful for what you'll learn about next week, which is the idea of linear functions. Because essentially, this way of thinking about the problem is a precursor for thinking about the linear equation y equals mx plus b, where b is your initial amount and m is the amount that you're increasing each time. Because in this case, the 3 is the amount you're increasing consistently, 5 is the amount you're starting with, and 10 is the number of times you're increasing by 3. So that's just kind of a little precursor for what we'll talk about next week. But your students, if you ask them to solve a problem like this, may solve it in multiple different ways, as I've shown here. And then once they have correctly solved how many pennies would be in the jar on day 10, you could say, okay, well, what about if we did day 100? And in this case, the students who tried it this way may be convinced that this is a more efficient way to go because it's way easier to do 3 times 100 and add 5 to find out that there'd be 305 pennies rather than doing 5 plus 3 100 times. Um, so you can say, okay, well, how many pennies would be in the jar on day 100? And then once they have figured out how to do that, then you can say, what if we had a variable represent the day number? So instead of having a number like 10 or 100, what if we just said on day D? And we use D to represent whatever day number it is. How would you figure that out? And then with their experience from finding it for certain numbers of days, they could figure out that you just need to do 3 times the number of days and then add 5. And obviously, these conversations would probably be spread out over multiple days. It's not like they're going to pick them up super, super fast. And taking the time to have discussions about the different strategies and talking about why this addition strategy is really the same thing as this multiplication strategy will all build their mathematical understanding of how to represent functions using number sentences. And it also builds their functional reasoning because essentially what they're finding here is a function because they're saying the number of pennies you have is going to be equal to 3 times the number of days plus 5. And so because you have these two variables that are being related by an equation, that's what makes this a function. And you can also do other types of functions. So you don't just have to do ones that are increasing by addition. You can also do ones that are increasing by multiplication. So you might say if you start with 5 pennies and each day the number of pennies doubles, how many pennies would you have on day X or day N or whatever variable you want to use? So I'm going to let you guys actually try this one on your own and see if you can come up with a function that says the number of pennies equals something that you do to the number of days. So I'll let you guys try that one on your own to practice your functional thinking. And if you have any questions, please let me know.